So we are looking at another given heat problem. And it reads how much lead, and you're given the specific heat capacity for lead. That's 0.130 joules grams degree joules over grams degrees Celsius. Can be changed from 8.7 degrees Celsius to 13.2 degrees Celsius by adding 7,450 joules of heat energy. Okay, so nothing changes here. First thing I have my students do is write down the formula that we're going to use to solve this science problem. And next, I have my students identify, just while I do this here, identify the variables we have, and that will help us to identify the variable we are looking for. So how much lead? And again, I said this earlier, this is probably the easiest one because our constant has that crazy unit. So my students would write this value in there. Decimal 130 joules grams degrees Celsius. I always write the units in. Units become very helpful later as we're solving the actual problem. Can be changed from 8.7 to 13.2, so the final temperature is 13.2, and we're going to subtract 8.7, and if I'm not mistaken, that would be 4.5 degrees Celsius. And here is this is our unit of heat energy here, 7,450 joules. So we are looking for mass, and I'd go back and I'd say, look, here it is here. How much lead? Well, how would you measure something that would read that way? How much of whatever the substance is? You're pretty sure you'd be looking for a mass. Okay, so let's go back to step 2, and we are going to plug in our values, and we're going to plug them in from here. So we have Q, and that's 7,450 joules. Mass, again, some might be comfortable writing it as either M, but typically I write in X because that is our unknown. However you're comfortable, feel free. 0 unit, our constant unit is joules grams degrees Celsius, and it is 0.130, and we have a change in temperature of 4.5 degrees Celsius. Okay, starting from the left and moving to the right, so we would rewrite 7,450 joules, and we would have this. So let's have a little look here. No value here, that's our unknown. Decimal 130 times 4.5, that gives us 0.585. Now let's look at what unit we have here. We have joules over grams degrees Celsius. We have a Celsius here and a Celsius here, so they will cancel, and we are left with joules over grams x, because this is our unknown. Now, basic algebra is what this comes down to, so we are going to divide through to solve for x, 585. This is why it's really important that you use your units, and I will show you why right here. 585 joules over grams, and of course all of this is going to cancel, and we are left with x here. Over on the left side, look, we're going to cancel out our joules. 7,450 divided by decimal 585, that gives us this value, 1,000, or 12,000, sorry, looking at my calculator here, 12,735 decimal 04, and that would be in grams because, look, that is the only unit that we have left. And hopefully the unit that you end up with is the unit of the variable of the unknown that you were looking for initially. Now we're not done yet. We have a large number here, 12,735 and change grams. And what we're going to do is apply our significant digits or significant figures, and then we're going to go back up for a problem. So here we have 3 significant figures. Here there are 2. Here there's no decimal here, so there's 3 there. There's 3 there, and our answer should be the same as the smallest or the least number in your problem. So in this case it's 2. So we are going to have 2 significant digits or significant figures in our answer. So we're looking at 1, 2. We're going to look to round. That's a 7, of course, greater than 5. That makes our answer, it can look like this: 13,000 grams. We could convert that to kilograms, which of course would be 13. There are, I'll go over here, 1,000 grams in a kilogram. Our problem used grams, so typically I'd have my students just leave it as grams, but sometimes you may have a situation in which you might have to make that conversion. If so, there's your conversion factor. And using significant digits, you can leave it like this, or sometimes you might just expressing your answer a couple of different ways here. 1.3 using scientific notation. 1.3 times 10 to the 4th power grams, and that one where all 3 of these work. Okay, thank you and have a great day.